Okay, this short video is about the general probability rules. We've looked at specific rules earlier in this chapter, but now we're going to look for some that apply to more situations. The pages you're going to read tonight, or with this particular section, is page 359 to 364, and the problems are 646, 51, 52, and 53. Just a few problems. Okay, so we've already seen the rules for specific events. And you've seen the 5 rules earlier, and they're repeated again in this chapter. Rule 1 is that for any event, the probabilities between 0 and 1 inclusive. If you add up all the probabilities in your sample set, rule number 2 says it should come out to 1. So the probability of the sample set equals 1. Rule number 3 is that the probability of the complement of any event is 1 minus the probability of that event. Okay. Rule number 4, the addition rule, it's only for disjoint events, says that the probability of A or B is equal to the probability of A plus B. Probability of A plus the probability of B. These are only for disjoint events. And then number 5, the multiplication rule, it's contingent on the events being independent. So it says if A and B are independent, then the probability of A and B is equal to the probability of A times the probability of B. Now, the union of any collection of events is the event that at least one of the collection occurs. So if we look at this graph here, this figure that we have on the screen, we have A, B, and C. All A, B, and C are disjoint. There is no overlap. And notice that we still have the sample space out here. So this is our universe space. And that's any of the probabilities that are left over when we were taking add all 3 of these up. Now, the probability that A or B or C occurs, A and B can occur, but not C, or A and C can occur. So any 2 of them can occur, or any 1 of them can occur. Not all 3 can occur, and maybe they all can. So there, but at least one of them. So at least 1, at least 2, or maybe all 3. And we say or A or B or C, and we add all of those up. So they have to be disjoint. And we can have multiple, we can have 6, we can have 12, you can have as many as you want, as long as they're disjoint. Okay, so what happens though if there is some overlap, they're not disjoint? What do we do? Well, that old rule, we're going to just toss it away. So if we notice this Venn diagram here, this is figure 6.10, it's it from your book, there is an overlap, and that overlap is the A and the B part, okay? So this is what that satisfies both A and B. And what's left over, so if the probability of A was 0.8 total, and this is 0.2, then this part out here would have to be 0.6. And we've seen an example like that before in class. Now the general probability rule that we have down here for any 2 events, this works. So if we have A or B, we don't care if it overlaps or if it's disjoint, because we can take care of that now. We just subtract off any overlap. If it's disjoint, then we don't have any overlap, and we have our old rule again. Notice that. And then right below it we have our rule and symbolism. Probability of A union B is equals to probability of A plus probability of B minus the probability of A intersection B. Same thing as we have above there. If there is no intersection, then they're disjoint events, and we have our old formula. Okay, last thing before we end this is here's a hint for problem 6.51. It says that the 3 major ways of getting caffeine are coffee, tea, and cola. And they give you these questions. It's very much like a puzzle. It's one of my favorite problems from the book. And you have to figure out these probabilities. Well, start with the middle and work your way out. That's the only hint that I'll give you on that one, but that's a biggie. So I hope you enjoy these problems. And if you have any questions, you can save them for me next time you see me. Thank you.